By finding the revolutions. All right, so what we want to do is we want to find revolutions per minute. So identifying what your units are, revolutions per minute. Okay, so I know I want to start with 1 revolution. Okay, so 1 revolution is equivalent to what? So again, when we go back up to 1 revolution here is the circumference. And so that's equivalent to a diameter 22. So that's our conversion factor is 1 revolution is equivalent to 22 pi inches, correct? So that's what we're going to start with. Those are equivalent to each other. And so now what we want to do is we want to convert this into the units. Okay, so we know that the speed is 45 miles per hour. So I'm going to convert from inches into miles first. So I have 12 inches is equivalent to 1 foot. Now I can convert out of feet. 5280 feet is equivalent to 1 mile. Okay, and so what I have is my conversion for miles is given in the rate, the speed. So I have 45 miles per 1 hour. Okay, so I've gotten rid of and converted out of all of my distances. I'm now going to convert into just my time. So I need to convert hours into minutes, and so that's 1 conversion. 1 hour is equivalent to 60 minutes. And so now I have my calculation to give me the number of revolutions or rotations. And so when I multiply that through, I get 12 times 5280 times 45. And I'm going to divide by 22. I'm going to divide by pi. And I'm going to divide by 60. I'm going to put it in decimal form, and that gives me my solution of 687.55 approximately. So those are my number of revolutions. Okay, so this is revolutions per minute. And so if I take that number, 687.55 revolutions per 1 minute, and I want to convert this into angular speed, and I see up here, angular speed is radians per time. The time is in minutes, so I already have per minute. All I need to do is rotate or convert revolutions into radians. And what is the equivalent there? 1 revolution is equivalent to how many radians? 2 pi. So my units cancel, and I get radians per minute. And so if I took this number right here and I multiplied it by 2 pi, I get my solution of 4320 radians per minute. And that would be my final answer.